Well, hello, everyone. Thank you for joining us. I am Rachel Paul with IAAP. And before we start today's program, I just have a few items to go over. We do have closed captioning provided. You can select the closed captioning icon on the bottom of your Zoom screen. And we will be providing stream text links in German, French, Spanish, and Swedish, and we'll have those posted in the chat momentarily. We also are happy today to have a Czech interpreters that will be translating live, and you can select the interpretation icon at the bottom of your Zoom screen and then select the Czech channel to hear those live translations. We do have attendee microphones muted to prevent any background noise or disruptions. And today's program will be recorded and made available on the IAAP YouTube channel. And we'll share that link out after the event. We will be monitoring the chat for any general dialogue and technical issues, and we encourage you to post your questions in the chat. Post your questions in the Q&A today, and we will get to those as time permits. And we have with us today, Susanna Lauren will be our host, and we have John Gibbins with us. So I'm happy to turn today's program over to Susanna.
Thank you, Rachel, and welcome everyone, and especially welcome to all of you who were registered for this event when it was originally planned. We had to move it, unfortunately, but now here we are finally in this beautiful winter day, and we're very happy to have John with us today to teach us everything about mobile apps and testing. But first of all, the Eurovision part of this. So, vous pouvez lire les sous-titres en français si vous suivez le lien fourni dans le chat. Sie können das auf Deutsch lesen, wenn Sie dem im Chat angegebenen Link folgen. Puedes leer el español si sigues el enlace provisto en el chat. Du kan läsa texten på svenska om du klickar på länken som vi lägger i chatten. And now I have to ask my dear friend Radek, who is volunteering for IAAP, the EU, to help me with the Czech translation of this, because that I can't do.
Dobrý den, pokud chcete sledovat živé tlumočení dnešní akce v češtině, tak si aktivujte tlačítko Interpretation s obrázkem globu, kde si vyberete kanál Czech a můžete sledovat nebo poslouchat živé tlumočení do češtiny.
Sounded perfect. I have no clue what you said, but I hope that is really helpful for everyone who can speak that beautiful Czech language. So, and thank you, Radek, for making this happen, the simultaneous interpretation. I think this is a big step for IAAP, that we are now moving more towards the eastern part of Europe as well, and welcoming even more members from other countries where English may not be the first language for everyone. So that is just what we are doing. This is the last webinar of this autumn. We are then going on holidays, and then we get back with more interesting webinars, and the newsletter, of course, keep on doing that in the springtime. And then we are planning for a face-to-face event in Brussels during the spring. So keep tracking and following us in all the channels where we are. But now I want to give the floor, or give the mic, or I don't know what I'm giving to to John Gibbins, who is one of the most clever people I know when it comes to testing of mobile apps, which is one of the most difficult things that most monitoring agencies and accessibility experts are really struggling with in the EU these days. So I'm very, very happy to introduce to you a person who can teach you everything, and you will be enlightened and know much more about this very interesting and important topic after today's webinar. So John will make the presentation first, and then we'll take questions afterwards. So just please put them in the Q&A, and I'll make sure that we respond to as many as possible from them. Okay, thank you. John, please.
Great, thank you very much, Susanna, for the wonderful introduction, and apologies that we had to delay this this session. I was unfortunately came down with COVID just before the last scheduled time for this event, and so I'll just share my slides a moment so we can get started. But hello to everybody who's joining us today, and thank you for joining us. I hope I can live up to what Susanna has said in my introduction. So yes, my name's John. I'm a digital accessibility consultant. I've been working in the field for nearly 20 years now, and I've been working on accessibility in native mobile apps for nearly 10 of those years. And over the next sort of 30, 40 minutes, I'm going to take you through what guidelines do we have for mobile, what does compliance look like, and we'll particularly talk about EN 301-549, and how do we test for compliance of mobile apps. There are lots of links to references and resources in the presentation notes, which I'll make the slides available. So don't worry too much if you miss something. Of course, it's being recorded as well. If we get time, I'll perhaps try to demo some of the testing tools that I talk about, but I have a couple of screencasts to some videos to show you of those things. So let's make a start. So guidelines and standards, what do we have when it comes to mobile guidelines? Well, many people watching will be aware of the Web Content Accessibility Guidelines, the current recommendation 2.1, version 2.1, published in June of 2018. Version 2.2 is on its way, due in the next month or two, with some additions that are relevant to mobile. I will discuss these and how they impact on standards like EN 301-549, but I won't be going into too much detail about those. Some of the W3C documentation, it relates to web much more than mobile. So what has happened over the years is we've had other mobile accessibility guidelines, Funke being one of the very first to produce a set of mobile accessibility guidelines for use with native mobile devices based on the Web Content Accessibility Guidelines. The BBC have also published some the mobile accessibility guidelines published back in 2014, including what was missing at the time. So a lot of there's techniques for using HTML in mobile web, some code to be used on Android and iOS, but it's in need of updating, which I understand is happening soon. New technologies, Kotlin instead of Java on Android, Swift and Swift UI instead of Objective-C on iOS. These code examples need updating. And of course, every year, iOS and Android have a new release, new APIs, new functionality that we can use to make our apps more accessible. So we need to keep these guidelines and resources up to date. iOS have their human interface guidelines, which have some items around accessibility. Been recently redesigned to be much clearer. Some, unfortunately, poor recommendations from an accessibility point of view, in my opinion, in there. Things like recommending placeholder text as form labels, which, as you may understand from web accessibility, is not ideal, and it's not ideal on iOS and Android either. So there's some items in there that I would disagree with from an accessibility point of view. Google and Material Design have their own set of accessibility guidelines, and as I say, there are links to these resources in the slide notes. There are some further platform-specific guidelines available in the resources at the end of this deck of slides as well. But these are kind of the main ones that are up to date. I'll talk more about some of the standards as well. So what does compliance look like? Well, I generally avoid talking about legislation, but what I want to touch on is legal compliance and what it looks like for mobile apps. So a lot of the law around the world currently either quotes Web Content Accessibility Guidelines Level 2 or version 2, conformance at level AA, or it's implied. So WCAG, as we call it, is a logical starting point when working with accessibility for mobile apps. Although I don't know of many that specifically mention mobile apps, but rather mention electronic content or software in general. And one in particular that stands out here is in Europe, we have EN 301-549, and that specifically mentions mobile apps and requires all mobile apps in the public sector to comply by June of this year. So we're now past that deadline. And new versions of the EU standard have been updated to reflect the new requirements introduced by WCAG. So let's talk about that for a moment. So this harmonized standard, it's been designed to be compatible with other accessibility standards and regulations while covering all digital technology, not just web. Mobile apps are covered by section.
I'm on my meeting.
Sorry, Susanna, I think you need to mute. Thank you. Mobile apps are covered by section 11 of the standard software, and I'll talk some more about that through the rest of the session. But I should note here that I'm focused on native mobile applications here, and therefore mainly on that section, and I'll talk about Annex A as well and how that can be helpful. I'm not going to cover voice communication, video, web content that's contained within a native mobile app, hybrid content, or digital documents that form or forms contained within a native mobile app, such as PDFs. These are covered by section 6, 7, 9, and 10 of the legislation. So what I'm mainly focusing on here is how we apply the Web Content Accessibility Guidelines as a framework through EN 301-549 to make our apps more accessible. Now, there's a lot of things I could talk about and that I could cover in this session, and it would go way over the time. So I needed to find a way to boil that down. So I've come up with a way of going through most things or the things that need particular interpretation when working with mobile. So forgive me for not going through absolutely everything. It just simply isn't the time to go through everything. But if you've already got an awareness of the Web Content Accessibility Guidelines, then you should be able to understand the things I'm going to talk about. So in 2018, the EN 301-549 standard was updated to specifically include mobile apps and reflect WCAG 2.1 conforming at level AA. And the most recent versions include further resources, including a table of minimum requirements for mobile apps in Annex A, which also serves as a helpful checklist, if you like, for conformance for mobile apps. And it's one of the few checklists that I know of for mobile apps. Another, Google have their own developer checklists to ensure accessibility of Android apps. So let's talk a little about the Web Content Accessibility Guidelines. It's been around for this version 2.1 has been around for a couple of years, and the general principles and guidelines that it outlines equally apply to native mobile apps. But we have a problem when we try to use the success criteria in WCAG to test and make native apps conformant. So problem number one, when we try to apply web guidelines to native software, there are bound to be issues. So version 2 of WCAG may have been designed to be applicable to technologies, digital technologies, but it still uses terminology and measurements for the success criteria that are specific to web technology. So it's missing platform-specific context and user expectations. Ever since the first smartphones, WCAG and its documentation didn't map very well to mobile. And this is why companies like Funke and the BBC ended up creating their own mobile guidelines. So today, being relatively new, WCAG 2.1 still uses terminology that doesn't match the context of native mobile, even though there are new success criteria that cover touchscreen technology and mobile devices specifically. Let's take a look at this. So some examples, we have talk of web content and web technologies in the success criteria, talk of web pages within success criteria, CSS pixels in success criteria thresholds, CSS being a web specific technology, talk of content implemented using markup languages. This might change with the next version of WCAG, currently called Silver. The W3C's Accessibility Guidelines Working Group is working to produce a set of guidelines that are applicable to wider technology. In the meantime, some WCAG success criteria can be applied to native mobile, as I like to say, in the spirit of their intended purpose, a phrase I borrowed from Patrick H. Lauker, a friend. When I'm writing accessibility audit reports for mobile against the Web Content Accessibility Guidelines, I will often use this phrase, because the tricky thing here is to decide whether or not something that is worded in a way that reflects web content is actually applicable at all to mobile apps, which is why EN 301-549 attempts to make that translation, which is great. So the issue, there is another problem, and this is more a personal observation, that web accessibility is not the same thing as native accessibility. It's not the same as software accessibility or mobile accessibility. This is why we need to have these interpretations. And we talk a lot about web accessibility, and that's no surprise really. We have the Web Content Accessibility Guidelines, the most widely accepted accessibility guidelines for digital products, which was developed by the World Wide Web Consortium, who are focused on the web. They do great work, but they're the international standards organization for the World Wide Web and develop web standards, not digital standards. Of course, as I said, changes are coming in that respect. Perhaps we need to be talking more and more about digital accessibility to encompass and include websites, mobile, and other digital presentations, and embrace that wider context of the work we do in this field. But for me, this is one reason that potentially the Web Content Accessibility Guidelines and its derivative standards don't translate well for working in the specific context of native mobile platforms like iOS and Android. By abstracting the WCAG success criteria to apply to software in general, rather than to be understood within the specifics of a platform like iOS and Android, its nuances, its capabilities, its user expectations, we end up with problems. So on one side, we have the problem that legislation cannot be too specific. So we end up with legislation that covers software in general. On the other hand, being too broad risks being too prescriptive or vague when it comes to applying those principles and success criteria to specific platforms in a meaningful way. So it becomes about translating standards for specific contexts. And this is why we need to have new resources that translate the great work of the Web Content Accessibility Guidelines and EN 301-549 to make sense within these contexts and to be narrower in application than the broader context of software in general. So the accessibility guidelines that we use need to acknowledge these different behaviors, but perhaps what we need is additional documentation, like we have the WAI ARIA authoring practices. They exist to translate the expectations of desktop applications and widgets into working in the context of the web. We need the same kind of translations for platforms like iOS and Android. And there are people doing great work in this area. Rob Whitaker has written a book on mobile accessibility and has mobileA11y.com with some great information on iOS and Android. APPT.nl are working on mobile specific translation of the Web Content Accessibility Guidelines for iOS developers and Android developers. So how do we interpret and working on interpreting those guidelines for the specific platforms? And I've started developing some on GitHub as well with some resources for Android and iOS around these ideas. Okay, so let's do a bit of translating. Now, first I must say, this is very small text. I don't expect you to be able to read these. I'll just tell you what's going on here. So this is a list of all 78 success criteria currently in Web Content Accessibility Guidelines 2.1. I won't be able to cover all of these today, but I can talk about the major stumbling blocks based on my experience. I'm going to translate some of these success criteria for use in native mobile apps and relate them to my test process. I'm going to assume that everybody here is familiar with WCAG 2.1 as it relates to web content. So what can we do here? First thing we can do is we can remove all the AAA issues that are not required for legal compliance. We are left with 50 success criteria at level AA. So sometimes I will test for some AAA issues and I will mark them as best practices. I'll talk more about those in a moment. One in particular, target size, I'll talk about. Let's remove some more. So remove another group. Some success criteria are essentially the same on mobile as they are for web. So there's not much point in me talking about these. For example, I'm not going to talk too much about color or multimedia video today, but I will talk about some of these others. I can remove text spacing. So we can remove that because at the moment, it's not possible for developers to control text spacing. Sorry, it is possible for developers to control text spacing. It's not possible for users to set their own user preferences of this, which is what the success criterion relates to. So I generally don't test for that one at this time. Of course, we can implement as such user preferences within our own app. It's just not available at the operating system level. So we can test for them and fail them if we wish. But that's the level at which we would need to implement that. Content on hover or focus. Well, this tends not to happen, or content on hover or focus tends not to happen on native mobile for the very reason that it's a touchscreen device. So we don't really hover on things. We have a long press. We don't really focus on things because we're generally not using a keyboard with these devices, although that is changing. More on keyboard accessibility later. So generally, this is one that doesn't apply at the current time. Bypass blocks. We tend to be working with much smaller screens, although we have tablet screens that are getting larger and larger. So this can be applied in some ways. Navigation menus are often revealed using a button, so they don't need to be bypassed necessarily. But when we're working in the context, when we're working with keyboard, there is increasingly changes to how native apps work. Again, I'll talk more about that later about keyboard, but there are ways that the operating systems themselves are providing aids for users using keyboard to bypass blocks without the need for app developers to implement these. So I currently don't test for this one very much unless I notice an issue, but it is applicable. It's just that currently either there hasn't been a way for developers to implement a solution, or the solutions are now currently being implemented at an operating system level, so developers don't need to do anything. So there are some uses here. There's some more notes in the slide deck. And one thing to note here is that bypass blocks is not required for conformance of the EN 301549. So there are some things to keep in mind there when working with particular standards. So multiple ways. The number of screens in mobile apps is typically small. And so I find this success criterion difficult to apply in a useful way. One example can be found in the settings apps of iOS and Android, where there's a search field that can be extremely helpful alternative to navigating through the menus, especially when Apple or Google have moved one of the settings that from one area of the settings app to another. So search can be considered a different way to accessing the content in that app. rather than navigating through multiple menus. But generally, multiple ways is not something that can be usefully applied to native mobile apps. Again, this may change. Focus visible. Generally, iOS and Android handle focus indication in apps for you. Common issue is experiencing elements that are not visible on the screen, but they do receive focus, which causes a multitude of problems or different types of problems. But generally, these problems are the effects of a different problem than visible focus. That said, there are ways to change the focus styles of apps or user interface elements in iOS and Android when using keyboard. But when using other technology, generally, the focus is something that's handled for you. Language. There's currently no way to specify the language of an app in iOS or Android, at least not for accessibility purposes. You localize an app to different languages, but this is not the same thing as identifying the main language for accessibility. So screen reader software on mobile platforms use the language that is set in the user's settings. Something we can do is identify changes in language within an app. So if you have an English app and then you have a part of the app is written in French, we can say, okay, this part is in French, and then that will cause the screen reader to use the correct speech output. So in iOS, you can control the language of individual views within your app where you need to. Currently, there is no way to do so on Android. So this covers language of parts on the Web Content Accessibility Guidelines. But note that language of parts is not required for conformance of EN 301-549. Last one, parsing. Now this is specifically related to markup languages, so it's not applicable at all to native apps. While user interfaces on the platforms are defined using a markup language, XML, generally the apps won't work if this is not well structured. So this tends to be something that is just not applicable to native. So what do we have left? So these are the items that we have left, and I found that some of these require interpretation when we're working on native mobile. So some of the remaining criteria are part of the 17 new success criteria. Oh, don't know what happened there. PowerPoint has crashed. So while I bring my slides back up and reshare them, some of these success criteria that we're going to work through relate to the newer Web Content Accessibility Guidelines 2.1 requirements. Where's my slides? No. So I'll talk through some of those, and then we'll talk about some of the others in the context of how I test an app, and hopefully I'll be able to demonstrate some of the tools that I use as well. Okay, just find the slide that I got to. Okay. Share my screen. Okay, sorry about that. Okay, so we have orientation. This allows screens to be used in either landscape or portrait, as some people cannot rotate their device. And I find it very common on native apps to lock a user to either landscape or portrait. Now, generally, it should be relatively straightforward to support both orientations. So it's fairly easy for developers to make a change to turn on support for those orientations. It's just about checking them. And these days we need to adapt our layouts and our views on mobile apps to apply to different screen resolutions and to different capabilities. So adjusting so that things automatically change layout for different orientations should be relatively straightforward to implement. But so support for orientation. So that can be checked by making sure that the orientation lock settings are turned off on iOS or Android, and then checking both orientations for a screen. Identify input purpose. People with mobility issues have difficulty in entering data into the field sometimes. People with cognitive difficulties may have difficulty remembering details. So there are identify input purpose provides support for tools that can help with this. And still, but some of the features on iOS and Android provide autofill functionality for apps. So both on iOS and Android, more recent versions of the platforms provide the values that are used in the success criterion, the HTML5 autocomplete values, allowing developers to specify whether a form field is expecting an email or the first line of somebody's address or somebody's city, that kind of thing. So those kind of things can be supported now and can be tested for at level AA. Another AA requirement, reflow. When we change the device orientation, we would expect that the content of our screens and mobile apps visually reflow without loss of content or functionality. And most of the time, I find that apps reflow with no problem. However, problems do arise when testing for support for Resize text, which we'll come on to in a moment. Character key shortcuts. This is rarely found in the wild, sometimes in mobile games, but the idea is to allow users to customize any keyboard shortcuts or turn them off. And character key shortcuts are becoming something that has greater support in recent versions of iOS and Android, so that's something to look out for. Pointer gestures. Anything you do using a gesture, essentially anything that isn't a straightforward tap on the screen, it should be possible to do that action in some other way. So this might be by providing a button alternative to pull to refresh or something like that. So some iOS and Android also provide support accessibility features to provide access to gestures for people who perhaps can't perform gestures on the screen. So there is also assistive technologies helping at the operating system level on both iOS and Android to solve the problem that this success criterion aims to solve. Pointer cancellation, where somebody where an action is performed when somebody releases their finger from a screen, not when they put their finger down. It helps to avoid any functionality that users have no way to cancel. And this is something that I rarely find happens, but and most of the time actions are performed on releasing someone's finger. Motion actuation. The movement of a device, such as shaking the device, must not be the only way that people have access to performing an action. And users should be able to turn off any such functionalities so they don't accidentally cause something to happen. So an example being shake to undo. And I remember some apps have shake to provide feedback. I believe Facebook had this, or there was a Maps app that also had this, where I would be out for a jog and it would be continually asking for my feedback because I was moving the device, and I would want to turn that off. So there are other reasons for having this functionality, but just like with pointer gestures, motion actuation, so moving a device, should not be the only way that a user has access to performing an action. Now that we've reviewed those Web Content Accessibility Guidelines version 2.1 success criteria, we have a small number left to discuss. And I interpret these success criteria with particular care when applying them to iOS and Android. These can be covered by telling you a bit more about my test process for mobile devices. So this is a summary approach of how I go about testing. Now, as an accessibility auditor, it's rare for me to have access to a code base. So analyzing code would be my first action. But of course, it requires access to the code. So this is something that developers can do to test as they build. And for iOS apps, Xcode, the development environment, doesn't currently have an accessibility linting tool as such, but it does have different tools that we will talk about in a moment. But this is changing. Let's talk about what's available on Android Studio. Android Studio has a linting tool that gives warnings about accessibility issues in your code. So this slide shows that the lint tool displaying some accessibility issues for an app. It's run from the menu, Analyze, Inspect Code, and then the results are shown under Android lint accessibility. And you can see some examples here of some of the issues that it can find. Accessibility in custom views, image without content description. This is essentially a missing text alternative for an image, missing accessibility label being very similar, and then keyboard inaccessible widgets. So these are all things we should be familiar with from working with the web content. Second, an automated scan. So just like with the web, around a third of the web content accessibility guidelines can be tested using automated tools, and comes with the same caveats. So whilst we may be talking about native apps here, we still have to interpret the results, as they can falsely report issues. So it's about understanding the results as much as getting results for accessibility issues. And several automated testing tools exist. Google provides Accessibility Scanner for Android. Apple provides Accessibility Inspector for iOS. It comes with Xcode. Both of these detect accessibility issues on your screens and then suggest how to fix them. So Accessibility Scanner. It's an app that you download to your Android device. You enable it in accessibility settings, and it adds a floating action button to your screen that you use to start the scanner. And it will find issues like missing text alternatives, missing labels, issues with touch target size, lack of support for resizing text, and color contrast issues. And so we go to accessibility, we turn on the accessibility scanner, and then we go to an app that we want to test. We activate the scanner. We can do it in record or snapshot. Snapshot will just take one screen. Record will go through a user journey and take multiple screenshots. And then it produces a report. So here we have a report that this item and another item has poor touch target size, and tells you the dimensions of those things, and provides information on how to fix those things. Accessibility Inspector comes with the iOS development environment Xcode, and it runs on your Mac. As its name suggests, it allows you to inspect your iOS app's interface for accessibility information. And this will work with the simulator on your Mac, or with an attached iOS device to test any app on that device. So how does it work? Well, it can check for very similar issues to the accessibility scanner on Android, missing accessibility labels or other information like state information, touch target sizes, support for dynamic type resizable text, and color contrast. So once we've got the device set up, we can inspect items on the device. So this is my device plugged into my Mac. And I've hit inspect and then tapped on an item, and it tells me information about that item. And then I can navigate through using these arrow buttons to navigate to other items and find out information about that and check the order of content. I can also run an audit, which, just like Accessibility Scanner, produces a list of items and provides an idea of how to fix those items. It also has support to check the display accommodations, so customizations that users can make, support for changing in text size, support for reduced motion settings for bold fonts to make things bold. We see things change as I select things on and off here, increasing contrast, the contrast changes on the app. And these are things that should be supported. Now, some of these items go beyond the scope of the Web Content Accessibility Guidelines and the EU regulation. But things like resizing text should be tested. And that can all be done, or some of those things can be done using this tool. And it can also be used to, this is inspecting the simulator. So if you do have access to the code and you run the simulator on Mac, you can also use the same tool to check accessibility in that. So this is a good place to talk about target size. It's when I run these sorts of automated tools, I find most issues around target sizes. As I said, this is best practice as a level AAA success criterion of WCAG 2.1 and is not currently required for conformance. So research shows that the tips of our fingers are around 7 millimeters by 7 millimeters, and we translate that for use in native mobile. Now, the Web Content Accessibility Guidelines say 44 CSS pixels. What does that mean? Well, they're essentially relative units, and we have relative units on iOS and Android. On Android, this can be interpreted as meaning 44 density independent pixels, or DPs. On iOS, this can be interpreted as 44 points. One note here is that Google recommend a minimum touch target size of 48 DPs, which relates to its grid unit of 8 DPs. So when you're running Accessibility Scanner, it will flag up any issue that any touch dimension that is less than the 48 DPs rather than 44. So bear in mind that's a difference in conformance level as well. So no, it's not required for conformance to EN 301-549. WCAG 2.2 that's coming soon will update the level AA success criteria. So look out for that. However, note that EN 301-549 is unlikely to get updated from WCAG 2.1 success criteria, at least not anytime soon. And I do have information about the requirements around that 2.2 will bring if anybody's interested. There are other automated tools. These are mostly for integrating with automated integrating with the development toolkit. So these help to stop changes in apps from breaking accessibility over time, and it helps keeps development teams on the lookout for accessibility as they work. Screen readers. It's important to test the actual user experience for people using screen reader software. So this will uncover many of the technical issues that automated tools do not. On Android, we have TalkBack, also known as part of the Android Accessibility Suite. On iOS, we have VoiceOver. So we TalkBack and VoiceOver, and both are powerful yet easy to learn to use compared to a desktop screen reader. And since the release of TalkBack 9.1 in February of this year, the ways that these two screen readers are controlled and operated are more similar than ever. The basics are that there are two main interaction methods used by both platforms. Explore by touch, you place your finger on the screen and you move it around. And as you move your finger, the items that are underneath your fingertip are described by the screen reader in audio speech. You double tap items to activate them. And then you can also move your finger around and tap with a second finger to activate them. This interaction is spatial. It requires users to become aware of the layout of a screen. So this can be a great way for interacting with on-screen keyboards, making on-screen keyboards more like touch typing. Another method is gesture navigation, which is what is used most of the time. This is sequential and typically follows the reading order of a screen. Users will interact with one element on a screen at a time and swipe left or right to move linearly through this order of content. And then once you've reached an item you want to activate, you can double tap on the screen and it will activate that item. Something that I check when I'm using a screen reader is page titled, and this is something that often doesn't come up in guidelines and standards. I test for this because I know it's possible to emulate what a web page does. So as a user moves from screen A to screen B, they can, the screen reader will announce the title of the new screen to let the user know that something has happened, but also to let them know where they are. It's not well documented for Android, but it's possible to use the activity title to do this, and it will behave as a web page does. Summary element for iOS is a little different and doesn't behave in the same way as a page title, but can be used to inform users of the current state of an app as they load it. So it doesn't change as people move from screen to screen, but it does let the user know where they are when they open the app. So that's another approach. Keyboard accessibility. This is typically where we look at the focus order on the web and other items like state and management of keyboard focus. While focus on mobile devices is similar, there are differences on native mobile devices. There are two concepts essentially. There's input focus and virtual cursor. So input focus is like keyboard focus on the web, where interactive elements receive focus in a sequence. The virtual cursor is more like the reading order. So the accessibility focus, as I call it sometimes, where all accessible elements are experienced and not just interactive ones. And that's read in a sequence by the screen reader. But on mobile, Android and iOS will go through things like links or buttons, fields, and other controls. But on Android in particular, there's a misunderstanding very often around what focus is. There is a difference between what the screen reader will go through, called the accessibility traversal, and then what the keyboard would go through, called accessibility, focus. So this is more interactive. But then focus is broken into two subsections. So while there's input focus, there's a linear focus called the tab order, or next focus forward. And then the other is a directional focus. So when using up, down, left, right, which items receive focus. And these are two separate concepts on Android. On iOS, there is support for keyboard. There are bugs with it at the moment, but users can navigate using the tab key, arrow keys, and then activate items using the space bar. And this typically uses the same functionality that VoiceOver uses to navigate through content. So there's currently less that you can do to implement specific keyboard accessibility differently from the screen reader on iOS, whereas on Android, you have a lot more flexibility in that sense. And lastly, I will test with voice to check some other items, like checking that items on the screen actually have either numerical labels, so a user can, using voice access, can say tap 12 and it will take them to the item labeled 12. This is voice access on Android. On iOS, we have voice control and it looks very similar, but we can have labels and checking that the text labels actually represent the things that that are visible on the screen. I will also check resize text, and I said I wouldn't talk about color contrast too much, but I check color contrast. So most modern websites have responsive designs that adapt and reflow to fit to small screens, and it's common to find that content on native apps reflows well as well. But it's often the adaptability to changes in text size that are forgotten. Now, when it comes to conformance, The Web Content Accessibility Guidelines and the derived standards requires us to test text at a size of 200%. Now, the problem is when translating this for mobile is that there's currently no way on either iOS or Android to set text at 200%. So we test using the closest setting. For Android, this means 132%, which is the largest setting in the font size settings. On iOS, this means stop number 10. You turn on larger accessibility sizes, and it presents us with more options. And on the slider, stop number 10 is roughly 235%. So it's more than the 200% required for compliance, but the stop below it is 194%, which isn't quite enough. So if we want strict compliance, then we should look at meeting the app that we're looking at should support text resizing up to that level. One thing to note, though, is that there are some issues around expectations of how things resize on iOS and Android. Number one, on iOS, when you resize text, tab items don't resize. Other things that don't resize include segmented controls. Instead, there is a different way to accessing larger previews of the text on these items. So when large accessibility sizes is turned on for text resizing, then we can actually hover over our finger and hover and hold our finger over these tab items, and a larger preview will appear. This is expected behavior, and therefore, technically, I believe, should pass. Whereas on Android, the text size does change for these sorts of interfaces, tab bars, but we end up with issues around truncation of text. Another thing that does not resize on Android is with font size settings is things like title texts in top app bars. And generally, this is because of restricted space. And finally, color contrast. And this is an easy one. I take screenshots, or as I'm doing an audit, one thing that we'll find color contrast issues is the automated tools. I will also take screenshots, and the automated tools don't always find every instance of a color contrast issue. So I will check these using a color contrast tool as well. So what does it mean to be accessible on mobile? Well, mobile accessibility is different to the web, and it's important to understand those differences. What does compliance look like? Compliance can be quite fragile currently because the guidelines and standards don't always easily translate to native mobile platforms, and specifically to iOS or Android rather than mobile native apps in general. So how do we test for compliance on mobile apps? Testing has some subtle issues to look out for, which I've learned from experience. And I hope that this talk will help you in navigating those issues. And I really appreciate you listening to me today. And thanks for listening. I guess it's time to take some questions.
It is indeed. Thank you, John, for this walkthrough. I know you have material for another 3 hours, but you could compile a kind of a focused speech for us. So we have some short questions. I believe we can manage to answer them. So we have a question around switch control. So when you talk about the differences between keyboard focus and screen reader focus, where does switch controls fit in there?
Okay, so switch control on iOS, there again, because we have an accessibility API that switch control uses, which it shares with VoiceOver, a lot of the behaviors are similar. So there are two things that in particular that come to mind. One, we have something called custom actions that both VoiceOver on iOS and TalkBack on Android have a way of gaining access to multiple actions on a single element. Now that's available to switch control users on iOS. It comes up as the first menu when you're using switch control. So you have access to advanced functionality like that. The order in which content goes through is defined by that same API. However, there are differences in grouping. When we're using switch control, it's beneficial to group items together. So perhaps you're going through rows of an on-screen keyboard before then selecting the letter that you want on that row. So there is additional API for checking grouping of things. So yes, it is important to test switch control as well. But it's that specific thing. So when we're checking things like focus order, as it were, then that applies to the relevant success criteria in WCAG. When we're testing for switch access and grouping, I guess we're fitting that into like information and relationships almost, but it's a user experience issue for switch control users to make that more usable. So how we fit that into the context of compliance and into the guidelines is up for interpretation. But that's the issue there. On Android, switch access on Android is not as advanced, but it does provide a means to group content together as well. But my understanding of that is that that is done for you in the background. So I don't think there is much control that developers have over that. So switch control, yes, definitely worth testing as an additional thing, keeping in mind that they are built upon the same accessibility APIs as VoiceOver. So yeah, I didn't include it in my slides, but I would test for that as well.
Okay, thank you. And kind of attached to that, is it necessary to test with physical keyboard?
Yes. So under the keyboard section, I didn't elaborate, I guess. There's testing for keyboard accessibility with the screen reader attached as well, because there are keyboard commands when running a screen reader. So we can attach a Bluetooth keyboard and then and navigate using the screen reader, but there's also just keyboard on its own. So on iOS, currently there are some issues. I know, for example, hybrid views, a web view embedded within a native app is currently not keyboard accessible, whereas it can be navigated using screen readers. So there's a problem there, but there are keyboard controls that should be tested as well. On iOS, the order of content, the focus order and that kind of thing, and the behaviors should be very similar, if not exactly the same as what VoiceOver does, because again, it's built on the same API. However, there are differences in how keyboard users interact with things to how the screen reader users interact with things. So there is more of a concept of grouping. So you can use the tab key to navigate to a widget and then use the arrow keys to navigate through things, whereas you would interact very differently with that using VoiceOver. So yes, I think it was item number 4 on my list is to test with keyboard alone. And optionally, I would say testing with keyboard and a screen reader at the same time. But generally, if you've used a screen reader testing and keyboard testing separately, then you've covered the bases. Keyboard definitely worth testing on Android because the keyboard accessibility API is separate from the API used for TalkBack. So I definitely test for keyboard on issues on Android because there is that separation.
Okay, so we need to wrap up very soon. We have a couple of questions left, so we will make sure that John gets to respond to this in writing. So every one of you who have participated or registered today, we can also send this to you in writing. But I think this one could be short, possibly. Okay. If developers use standard components, but accessibility issues still arise, would you advise to develop less robust workarounds or keep it as it is?
Generally, if you're using the standard UI components to do things, you have 90% of the accessibility there, and it's pretty hard to break the accessibility if you know what you're doing. If you're building things on top of standard UI components, then it's relatively straightforward to make something accessible. So I don't think that there should be a reason not to make something accessible. But you know, we very often go down the route of making something custom because we want a particular behavior. So hopefully that kind of answers that question anyway, but I'm happy to answer further in text.
Okay, thank you very much, John, for this. It's very, very good listening to you as always, very interesting, and I always learn something new. So I don't know if Rachel has some closing words and updates or links or anything you want to wrap up with.
I just want to thank you both for joining us today. This was our last webinar in the fall series. We will make the recording available, and John said we could share his slides, so we'll send out a follow-up email to that. I posted earlier in the chat the link to to sign up for the EU newsletter that I'm not sure when the next one will be coming out, but I'll go ahead and post that link again if you didn't catch it earlier. That's a great way to stay up to date on what is going on in the EU events and upcoming webinars. And we'll be doing these again in the spring. And I think that's all I have. I want to thank our captioner and our interpreters today for being here. It was great to have all the different languages available.
Okay, so thank you everyone, and thank you for following us the first year of the EU initiative in IAAP, and we look forward to next year, upcoming year, even more interesting things, and hopefully meeting each other in person. So look up for the updates on the event in Brussels. And thank you again, John, for joining us today, and stay safe, everyone. Bye-bye.